So our next question is based on reduction formula. First we have to find for the integral of sin x power n dx. Okay, so we'll consider in definite integral is equals to integral sin x power n dx. We can write this term as integral sin x power n minus 1 into sin x dx, right? Here if the bases are equal we can add the power, right? So here if the power is nothing, so it is 1. If we add up here, so that minus 1 and plus 1 gets cancelled, so we'll be remaining with sin x power n, which is the same as our function given in the question, right? Here now we will use the formula of this, will consider as f of x and this term as g of x using the rule of Euclid, right? Now this is integration by parts method. Integral of f of x into g of x dx is equals to f of x integral g of x dx minus integral f dash of x into integral g of x dx whole dx. This is the formula by integration by parts method. Okay, this formula is used to solve this question. Now we know that f of x is equals to sin x power n minus 1. Now we'll find the value of f dash of x, which will be equals to, here we'll use a formula of x power n derivative, which is equals to n into x power n minus 1. So here n value is n minus 1 and again minus 1 will be n minus 2 into, we'll write this derivative again because this was not x. So sin x derivative is cos x. Okay, and again we'll find integral of g of x. G of x is sin x. Integral of g of x dx will be integral of sin x dx, which is equals to minus cos x. We'll find this first and we'll substitute in the given formula. So we'll get in equals to, first is f of x, which is sin x power n minus 1 into integral g of x dx value. Integral g of x dx value is minus cos x, right? Minus integral. Now f dash of x value, which is equals to this, we'll write this here, n minus 1 into sin x power n minus 2 into cos x. And next is integral of g of x dx, which is equals to minus cos x whole dx, right? Yes, so our equation will become in equal to, this minus will write first, minus sin x power n minus 1 into cos x, right? And here this minus and this minus get multiplied, so this becomes plus, and n minus 1 I'll write outside as it is a constant term. Integral sin x power n minus 2, here cos into cos will become cos square x dx, right? Now we can write cos square x as 1 minus sin square x. In is equals to minus sin x power n minus 1 into cos x plus n minus 1 integral sin x power n minus 2 into 1 minus sin square x dx. Now multiplying it inside, so in is equal to minus sin x power n minus 1 into cos x plus n minus 1. Here it will be integral sin x power n minus 2 dx minus, here if we bases are equal, power should be added. When we multiply with the second term, the plus 2 and minus 2 gets cancelled, so we'll be remaining with integral sin x power n dx, right? Now this is nothing but our question, right, which we have considered, right? So this value is of the value of in, and this value is nothing but in minus 2, right? The function is of minus 2, right? So we can write here in equals to minus sin x power n minus 1 into cos x plus n minus 1 into in minus 2 minus in, right? Multiplying this term inside, we'll get in is equals to minus sin x power n minus 1 into cos x plus n minus 1 into in minus 2, and next it will be minus n minus 1 into I. Now transposing the in term, this one to that side, we'll get in plus n minus 1 into in equal to minus sin x power n minus 1 into cos x plus n minus 1 into in minus 2. Now multiplying in inside here, so it will be in plus in minus 1 into in is minus in is equals to minus sin x power n minus 1 into cos x plus n minus 1 into in minus 2. Here the positive and the negative gets cancelled, so we'll be remaining with in is equals to minus sin x power n minus 1 into cos x plus n minus 1 into in minus 2. Now bringing this n here, so we will be remaining with in is equals to minus sin x power n minus 1 into cos x by n plus n minus 1 by n into in minus 2. Now in the question it is given to solve for n value of 4. We'll put n is equal to 4. So now putting n is equals to 4, we get I4 is equals to integral sin x power 4 dx is equals to, here it will be minus sin x cos x, here 4 minus 1 will be 3 by 4 plus 4 minus 1 will be 3 by 4 into n minus 2 is 4 minus 2, which is I2. So we'll get minus sin cube x into cos x by 4 plus 3 by 4 into, now we will solve for I2. So in this equation again put the value of n is equals to 2 here. So it will be minus sin x, 2 minus 1 is 1, so it is sin x into cos x by 2 plus 2 minus 1 will be 1 by 2 into, here it will be 2 minus 2 will become 0, so it is I naught. So that will be equal to minus sin cube x into cos x by 4 plus into minus is minus 3, 4 2 the 8 into sin x cos x, 3 1s are 3 by 4 2s are 8. I naught value, we know that in is equals to integral sin x power n dx, right? Now I0 means integral sin x power 0 dx. So anything power 0 is equal to 1. So it is 1 dx. 1 dx integral is x. So here we'll get x plus c. So this is our final answer. Next reduction formula is for cos. We have to solve it similarly as sine. So here the given integral is integral of cos x power n dx, right? For this also we can write it as integral cos x power n minus 1 into cos x dx, right? When we add the power of these two cos, we'll get as cos x power n, right? The same function. So consider this as f of x and this function as g of x, right? So we are having f of x is equals to as cos x power n minus 1. We'll find the value of f dash of x, which is equals to x power n derivative. So n into x power n minus 1. So it is n minus 1, minus 1 will be n minus 2 into, this was not x, so we'll write the derivative of cos x. Cos x derivative is minus sin x, and g of x is equals to cos x, integral of g of x is equals to integral of cos x dx, which is equals to sin x. Okay, now writing the formula of integration by parts method, integral of f of x g of x dx is equals to f of x into integral g of x dx minus integral f dash of x into integral g of x dx whole dx. Okay, you have to remember this formula in order to solve the reduction formula problems. Okay, this is very important. So it will be in is equals to, now f of x value is cos x power n minus 1 into integral g of x value is sin x minus integral f dash of x value you have to write, which is n minus 1 into cos x power n minus 2 into minus sin x, and again the integral g of x value will be sin x whole dx. Okay, now in is equals to cos x power, sorry, here it will be minus, no, it's right, it is plus only. So cos x power n minus 1 into sin x, and here this negative becomes positive, and n minus 1 I'll write it outside, and integral of cos x power n minus 2, sin into sin will become sin square x dx. Right, now we can write sin square x as 1 minus cos square x. So it is in is equal to cos x power n minus 1 into sin x plus n minus 1 into integral cos x power n minus 2 into 1 minus cos square x dx. Right, in is equal to cos x power n minus 1 into sin x plus n minus 1 into multiplying this inside, so it will be integral cos x power n minus 2 dx minus, here when we see the powers, so minus 2 and plus 2 gets cancelled, so it will be integral cos x power n dx. Right, this value is our question, which is equal to in, and this value is in minus 2. So here in is equals to cos x power n minus 1 into sin x plus n minus 1 into in minus 2 minus again n minus 1 into in. Transposing this term to that side, will get in plus n minus 1 into in is equal to cos x power n minus 2 into sin x plus n minus 1 into in minus 2. So multiplying in inside, so it is again in plus n in minus in is equal to, here everything will be remaining same, into sin x plus n minus 1 into in minus 2. Here this gets cancelled out, so we'll be remaining with n in is equal to cos x power n minus 1 into sin x plus n minus 1 into in minus 2. Now bringing this n over here, so it is in is equal to cos x power n minus 1 into sin x by n plus n minus 1 by n into in minus 2. So we got the value of in. In the question it is given n value is given as 5. So we will substitute here. So it is I5 is equals to integral cos x power 5 dx. Now substitute n value as 5. So we'll get here as cos 5 minus 1 is 4 into sin x by 5 plus 5 minus 1 is 4 by 5. I5 minus 2 is 3. Okay, now again it can be written as writing this same by 5 plus 4 by 5 into I3 we have to solve, right? Again putting n value 3 in this equation. So we'll get cos x 3 minus 1 is 2 sin x by 3 plus 3 minus 1 is 2 by 3. 3 minus 2 is 1. So it is I1. Now cos x power 4 into sin x by 5 plus 4 by 5 into cos square x into sin x by 3 plus 2 by 3 into I1 value. We know that In is equals to integral cos nx dx, right? So here I is equal to 1 and n is equal to 1. So integral cos x power 1 dx. So it is integral of cos, which is equals to sin x, right? So here we'll get as sin x plus c. Okay, now multiplying this 4 by 5 inside, so we'll get cos x power 4 into sin x by 5 plus 4 cos square x into sin x by 5 3 is 15 plus 4 2 is 8 by 15 sin x plus c is the answer.